This is Proofs Day 2. We're on page 5 of the student note packet, and there are 3 examples we're going to walk through, and then you guys should be able to get started on your homework. So again, talking about proofs, when we're proving equality, you're going to pick one side of the equation to work with, and then you won't touch the other side. I always like to draw a line kind of down the middle at the equal sign, and that kind of helps me keep track of what side I'm working with. Second thing is, pick the side that looks more complicated. And generally, that's a good rule in order to figure out what side you want to start with. So I'm going to start with the right-hand side in this example, only because it's a fraction. The other side is also not super short, but when I start with the right-hand side, I have some places to go kind of immediately. One thing we talked about in the last lecture, one of those tools that we have for solving proofs, is multiplying by a special form of 1. And so that's what I'm going to do with this right-hand side. And that special form of 1 is going to come from the conjugate of the denominator. Now, it's an Algebra 2 term that maybe you haven't heard in a while. But the conjugate of the denominator takes the sign between the two terms of the binomial, and it just switches it. And this is just going to be a tool that you start to use as you start to do more proofs. There's no common denominator to find because there's no two fractions being added together. We just have a single fraction. And so multiplying by a special form of 1, as we'll see in a minute, is going to help us kind of work some stuff out. So on the top, I'll just distribute the cosine. That becomes the cosine of u minus the sine of u times the cosine of u. And then on the bottom, 1 plus sine u times 1 minus sine u, that's just 1 minus sine squared of u. And so it's a little bit tricky to see where we're going to go from here, but the top, we did this in the last lecture as well. I actually find it better to not multiply everything by cosine. So I'm going to pull the cosine out of the top, and then in the bottom, 1 minus sine squared of u, that's actually cosine squared u from the Pythagorean identity. So this is actually the first identity we've used. Everything else has just been math. We don't have to write anything else. We just want the names of the properties being used. From here, we can see the cosine on the top is going to cancel with one of the cosines on the bottom. And I have 1 minus sine u on the top over cosine u on the bottom. That's not quite what we want. We want secant u minus tangent u. And so what I can do, again, using math, is I can separate all the terms in the numerator, put them over their own denominators. We find 1 over cosine u minus sine u over cosine u. Well, we're going to have to do this in a couple steps because they have different properties here. But 1 over cosine u, that's secant u. That comes from the reciprocal property. And then the very last step here, and I've got to do it in a separate line, sine over cosine is tangent. So secant u minus tangent u, and that comes from the quotient property. So I have to show this on different steps or different lines because they're different properties. There we go. We've got what we want on the left-hand side without actually touching the left-hand side. All right, so with example B, I'm going to start by dividing this into two sides, left and right, and then we're going to pick one to work with. Now, looking at the left and the right-hand side, I don't think any one is more complicated or less complicated than the other. I'll just work with the right-hand side here because that's just what I'm going to choose. So we have the cotangent of v plus 1 over the cotangent of v minus 1, and we want to prove that it's equal to 1 plus the tangent of v over 1 minus the tangent of v. And I'm going to do this in a slightly different way than we did the last one. Before I multiply by the conjugate of the denominator, or get that fancy form of 1, I'm going to try and think about a different way that I can get tangent into this right-hand side. And what I can do is pick a different form of 1 to multiply by. So I'm going to take the right-hand side here, and if I multiply by the tangent of v over the tangent of v, then something nice is going to work out here. That's just a math step, so I don't need to worry about showing or naming a trig identity. But when I distribute the tangents here and here, well, what do we get? Well, I'm going to show this step here. We're going to get the tangent of v times the cotangent of v plus the tangent of v. because 1 times tangent is tangent. This is all over, again, the tangent of v times the cotangent of v minus the tangent of v. And then I can use the reciprocal property. Tangent times cotangent, that's just 1. I'm going to name it. And in 3 steps, we got to what we wanted to show here. That the cotangent of v plus 1 over the cotangent of v minus 1 is equal to 1 plus tan v over 1 minus tan v. Okay, last problem for today. I'm going to put a line down the middle of the equal sign, pick a side to work with. In this case, I hope we all see that the left-hand side might be a little bit more complicated, give us some options to work with here. In this example, we've got 2 fractions being added together on the left-hand side, so my first thought here would be to find a common denominator. The common denominator then is going to be cosine v times 1 minus sine v. So I'm going to start by finding that common denominator. I need 1 minus sine v to be multiplied by itself, and then cosine v is going to get squared, and that is all over cosine v times 1 minus sine v, that common denominator here. Okay, math is being used, no trig properties yet, so we move on, nothing to write there. 1 minus sine v times 1 minus sine v, I'll do the foiling there. That is 1 minus 2 sine v plus sine squared v. And then we still have plus cosine squared v on the top. And this is all over still the cosine of v times 1 minus sine v. Alright, now is where we can start using our trig identities. I see a sine squared plus a cosine squared, and that is always just 1 from the Pythagorean. So my next line, the numerator is going to become this one here plus another one. So we have 2 minus 2 sine v over cosine v times 1 minus sine v, and that comes from the Pythagorean identity that we just used. And then in our numerator, I have a common factor that I can pull out here. That 2 is in both of the terms. That's just a math step. But now I see something cancels on the top and the bottom. The 1 minus sine v's factor, those factors in the top and the bottom, they go away. And so we're left with 2 over the cosine of v. Now, one last step here. Remember, we're trying to prove that this is equal to 2 times the secant of v. So I have one more trig identity to apply here. That is the reciprocal property. Alright, so on your homework, just make sure you're showing all the steps that you need to. Pick a side, stick with that one side, don't touch the other side, and email me if you have any questions.